Behind me is a mock-up of the V-280 Valor, an effort that started in 2013, really focusing on future vertical lift, and we had to focus on speed, range, payload, reliability, and survivability. So when we set out to configure an aircraft that would meet those requirements, we're really focused in large part on range and speed, or really reach. And so we came up with a tilt rotor concept based in large part on lessons learned from now over 600,000 flight hours on the V-22 first generation combat proven tilt rotor configuration. So when you look at range and speed, there is nothing more efficient and nothing faster and nothing more proven than the tilt rotor configuration. So that's really what you see behind me here with the V-280. What is a tilt rotor? A tilt rotor is an aircraft that we've developed to have all the agility and maneuverability of a helicopter in a low speed environment, but all the speed and comfort and efficiency of a turboprop in a high speed environment. So we've taken the V-22 Osprey, as I mentioned, we've taken the lessons learned from that, but we really did a clean sheet design for the Army air assault mission. So when you look at the configuration of the aircraft behind me, we've got 6 foot wide sliding cabin doors for easy ingress and egress. We've got the soldiers sheltered by the wing for deployment of a fast rope or use of litters. We've got a non-rotating engine and nacelle that we use for the aircraft to improve reliability and to preserve the field of fire and field of view for those in the aircraft. But we have maintained the key parts of the tilt rotor again, which are the ability to have that long range and high speed and efficient cruise. What's been neat about the V-280 Valor is it's been a clean sheet design using the digital thread or digital engineering. So not only are we able to take those 3D models and repurpose those from engineering to manufacturing, or from engineering to sustainment. And as you look around our booth here at AUSA, we've got a lot of visuals and a lot of demonstrations of how we use that digital technology through the life cycle of the aircraft, from production through sustainment. And the JMRTD effort and the effort that we're in right now, the competitive demonstration and risk reduction phase, is a perfect example of the application of that digital thread and how that improves the affordability, the quality, and the reliability of aircraft going forward. Since 2013, we've been engaged very closely with the Army, very transparently in the JMR program, showing them how a tilt rotor can meet those needs. We've had a great experience flight testing this aircraft. We flew this aircraft on time in 2017. We've flown it for years. We've put over 214 flight hours on it. We've achieved up to 305 knots of true airspeed. We've demonstrated low speed agility. We've demonstrated the ability to sling load, deploy a fast rope, integrate new technologies like a distributed aperture system or tactical data link. So we've done all this with the Army hand in hand. We've also had the opportunity to have 5 Army pilots fly the aircraft over 15 sorties. And so when you look at proving tilt rotor technology, improving how tilt rotor technology can be applied or is applicable to the long range assault mission, I think we spent a lot of time focusing on that.
We have designed Defiant X starting in the same operational footprint of a Black Hawk, and that's very important for the reasons everything you can do with the Black Hawk today in the air assault mission, the future long-range assault mission, you need to be able to do that you do with the Black Hawk today. So with the compound coaxial rigid rotor system, the pusher prop, we're going twice as far as a Black Hawk, twice as fast as Black Hawk, and can pick up a significant, external load, sling loads, to include the M777 howitzer. So an incredible transformational capability that Defiant X is going to bring to the future, commanders that are out there fighting in the years 2030 and beyond. Affordability has been key from the beginning, from the first design when we started designing the aircraft. And I think the power of the Boeing company as well as Sikorsky Lockheed Martin, the best of breed of both companies. So from the worldwide supply chain that both companies have today to manufacturing, advanced manufacturing techniques, how we're going to produce the aircraft is really driving affordability from not only building the aircraft but also sustaining the aircraft. We're bringing the lessons learned from over 50 years of experience with the Army in the rotary wing business. You know, those tactics, techniques, procedures, supportability, sustainment, all those have culminated in Defiant X, and we think it's a transformational capability that will give the ground commanders of the future the capability to win on the modern battlefield. When we have designed this aircraft, we have used the most advanced, analytics to design the aircraft, so understand the probability of when maintenance will occur, and also from the design perspective. I mean, the systems engineering that has gone on to this aircraft, has made us to be able to move into the prototyping phase very quickly with a high level of confidence. We've done significant amount of component testing, wind tunnel testing, and really those models have turned out to be, the aircraft when we flew it has turned out to be very accurate. Those models have been very accurate because of the engineering effort on the front end. Really, most importantly, as these aircraft are going in on this air assault mission, those dark nights in a formation of aircraft landing so the infantry can get out on the objective, sometimes under fire. This aircraft is the same size as a Black Hawk, and level body acceleration and deceleration. The difference between the helicopters of today and this aircraft is obviously speed, which 2030 and beyond is going to be necessary, and a high degree of maneuverability and agility, which is going to be very necessary to survive 2030 and beyond. But again, that ability to fly up to a landing zone, level body deceleration, and get on the ground as quickly as possible, take off with the prop, advance the prop, and accelerate away out of harm's way is something that, quite frankly, no aircraft today can do. So we're very excited about what the X2 configuration brings to future long-range assault, and we think it'll make a difference in the future. Again, it's speed and endurance. The way this aircraft, with X2 technology, fly-by-wire systems, the rigid rotor, compound rotor, the prop, you're able to fly very low and be very agile. And that low, flying in the clutter is extremely important. And then the range. We have significant legs on this aircraft. We can really have a long range assault, just like the name. So again, getting there is important. You're exactly right. But also, once you get there, being maneuverable enough and agile enough to get into tight, small LZs, in formation, to mass the infantry where the infantry needs to be in the conduct of the air assault mission is very important. And Defiant X was designed for that.